Hello. The question we would like to answer today is this. How much time would we expect to need to drive a certain distance, starting on a Monday morning from my home? Um, Google Maps is a good way to find that out. So, for example, here is from my house to Paris. We'll try to find a general pattern using my program FittingKVdm. I collected a lot of driving times in a file. So what do we have here? So the x is the distance in kilometers and y is the expected driving time. Now in this program you have to enter a confidence interval. So 4.2 kilometers, it's rounded to 0.1 kilometer. So it means the maximal deviation is 0.05 kilometers. Google gave a driving time between 6 and 14 kilometers in this case. So that's 10 plus or minus 4. So these are all the places I entered. Now, what would be the relationship between the distance and the time we need to drive it? Well, maybe linear would be a good idea. We'll try this first. Linear. Let's adjust the scale a bit because we don't have negative distances. So, okay. We can see this bigger. Now, we have to adjust the parameters from this model. Y is ax plus b. Now, driving distance of a distance of 0 kilometers should be 0 minutes. So the intercept b should always be 0. So we make it inactive. And now we start, make a guess. This is the first guess. And now we iterate. Okay, it's stable. So what do we see? Oops. Of course, if we drive longer distances, the time per kilometer extra is going to be lower because for short distances we will have mostly small roads with speed limits, and for bigger distances we can use more highway. So the points representing further distances will lie below this line. So we need another model. Power function might be a better idea. That's like the linear, but without the b, but with an exponent. So power, that is y is ax exponent b. So we can expect the b to be a bit less than 1 because it looks a bit like a square root function. So first guess, you see the exponent is lower than 1, but we have to iterate now. Iterate more. We check here if the parameters stay stable, then we can stop. Okay, that seems to be it. So that looks more like a good fit. Um, so here is Berlin, here is Nantes, here is Dijon, Caen. So for a smaller distance, we need, in comparison, a bit more time than for a longer distance, which could be expected. We can also see which connections are good or bad. So the points, we can make this bigger. And this is, for example, Brussels and Antwerp. They are much above the curve. So it means time is much longer than you would expect. So this is a bad connection from my place to these cities. Here, Ostende is for me a better connection because I relatively need less time to do a similar distance. So all the points below the curve have a good connection to my place, and the points above have worse connections. So now we can ask how much time will we need, for example, to drive 200 kilometers. Okay, that will be 169.4, etc. minutes. Or we can ask, how far could I get in 2 hours? 2 hours, that's 120 minutes. Okay, we can expect to get 132.6 kilometers on average if we start on a Monday morning. Now, how precise are those parameters A and B? Based upon the given deviations of the x and y values. All we have to do is click here, estimate parameter confidence intervals. So we see A is 1.97 plus or minus 1.56. So it means it's it's quite bad, but that's a worst case scenario since these segments here, the deviations are really worst case scenarios. So these are also worst case scenarios. The exponent is better, 0.84 plus or minus 0.14 approximately. So the lines you see here are really absolute worst case scenarios.